3020. Here I have expanded the serial interface relay controller by cascading two additional 8-bit shift register ICs with their outputs wired to form a second 8x8 matrix. The idea being that the matrix on the left represents 64 columns, while the matrix on the right represents 64 rows, providing 4,096 combinations capable of driving 2,048 dual-coil latching relays. To accomplish this, the 128 segments need to drive 128 switching components that provide isolation between their inputs and their outputs, such as reed relays or optocouplers. The outputs from each of the 64 components driven by the rows matrix should have one lead connected in common to VCC to provide source current to the latching relays. The remaining leads from the switching components can be connected directly to the source side of the latching relays, while the outputs from each of the 64 components driven by the columns matrix should have one lead connected in common to ground or VDD to sink current from the latching relays. The remaining leads from the switching components can be connected directly to the drain side of the latching relays. Control is accomplished by shifting in 32 bits at a time, the first 8 bits representing the rows matrix row, and the second 8 bits representing the rows matrix column, the third 8 bits representing the columns matrix row, and the fourth 8 bits representing the columns matrix column, thus creating a 4 of 32 input types.